So good morning everyone. So we are here to discuss about the parabola. So the parabola is a set of all points in which a line called directrix and a point called foci are equidistant to each other. So this picture shows how does parabola looks like. If you can see this box, eccentricity is equal to 1. This is how much the curve will be deviates from being circular rather. So in this case, if E is equal to 1, then we should say it is parabola. So it's because it is very understood that it will be equal. It is very equal for that. The line here, which is intersects the axis, is called the directrix. And this point here, that is behind on this point, is called the foci, and the midway between directrix and the foci is called the vertex. And this is where the curves takes place. And now we're gonna use the equations given by the following vertex point. So if the y squared takes place, y squared is equal to 4px will be due. Where the vertex is at origin, the foci is p0. Directrix is x is equal to negative p, so negative. Axis of parabola is on the y-axis, and it will open to right if the p is greater than 0, and opens to the left if p is less than 0. Now, if x takes place, so we will use x squared is equal to 4py, where the vertex is at origin also, the foci is 0p, and the directrix is equal to y is equal to negative p rather. Axis of parabola is on the x-axis and will opens upward if it's greater than 0, and opens downward if less than 0. Now let's look at an example. X squared is equal to 4y. So in getting this, we have to look only p. And we will now find the properties given. Since it is x squared, so we will use x squared is equal to 4py. Now, in finding the p, you have to take a number that will multiply by 4. It will be satisfied from the given term. So in this case, x squared is equal to 4 times 1, because 4 times 1 is 4, and it will be satisfied here. Y and y. Then, therefore, the p is equal to 1. And now we will now move to the properties. Also, the vertex here as origin, and now the foci is 0, 1, because if you can see, the foci here is 0p, okay, 0p, and our p is equal to 1. The directrix sorry for this bracket. Directrix is y is equal to negative 1, since it's negative p. And also the axis of the parabola is on the x-axis. And now we'll try to graph it. You must follow the properties so that you can identify where does the parabola will go. And now, after we have been drawing the Cartesian plane, we will now looking if it is right or left. Since p is equal to 1 and it is greater than 0, then it will go upward. Since it's x squared, we will use upward or downward opening of the parabola. So if p is equal to 1 and the p is greater than 0, then it will be upward. Hence, our vertex here is on the origin. right? And our foci is on positive 1. So let's positive 0, 1. And our directrix is on negative 1 also, here. This is our directrix. So we will try to keep there. And our axis is on here, the axis of symmetry. And now we will now try to grab it. We will now try to draw. So here it is. This is the graph of the x squared is equal to 4y. By the way, this line that passes through the foci is called the latus rectum. Next, y squared is equal to 20x. Now it's 20x. Now, all you have to do is to find a number that will satisfy the 20x term. So it means that it will be 4 times 5x. Since 5 times 4 is 20, then it will be satisfied. So therefore, our p is equal to 5. Now let's move to the properties. It is very understandable if you always look for the missing terms. So again, our vertex is at origin. Our foci here, since it's y squared, so it will be 5, 0. And our directrix will be x is equal to negative 5. And also, our axis of the parabola is on y. So let's graph it first before we'll go to the opening section. Now, since it is y squared, we will use the left and the right opening. So since it is greater to 5 also, then we will use the right. Now our vertex is origin, and our foci here would be something like here. Yeah, it's foci. Together with our directrix, which is x negative 5. So here. So let's grab it. And we're done. Let's grab it now. Since it is open to the right, it will look like this. And done. This is now the graph of the given equation. Now let's move now to our x, our vertex whose points are on any. So since we are now done in the origin, let's go now to the other ones. If y minus k time to the power of 2 takes place, we will use this. Y minus k quantity squared is equal to 4p x minus h, where our vertex is at any point, and our foci is p plus the abscissa point and the k. The directrix is x is equal to negative p plus h, and our axis of the parabola is on the ordinate point. If x minus h quantity squared takes place, we will use this. So x minus h squared quantity squared is equal to 4p y minus k, where our vertex is on the any point also, and the foci is h and p plus our ordinate point, and our directrix is y minus negative p plus k. Axis of the parabola is on the abscissa, which is in the x. And for the y minus k quantity squared, it will be similar to y squared opening session. If it is greater than 0, then it will open to the right. And if it is lesser than 0, it will open to the left. And for the x also, if upward, then the p must be greater than 0. And downward must be p will be less than 0. Okay? So we will use the example later. For y is equal to x squared plus 4x plus 8. Now, what we have to do now is we have to transfer this 4y into here. Okay, so hence we have to regroup. So x squared minus 4x is equal is equal to negative 4y plus 8. I'm back. Sorry for the inconvenience. It's positive. Okay, it's positive. So right now we have to complete in the square. So x squared, you know how to complete in the square, right? So you have to divide the 4x and multiply by itself. So 4 divided by 2 is 2, and times itself will be 4. So 4x plus 4 is equal to 4y plus 8 plus 4. And we have to factor this. So x plus 2 squared and 4y plus 12. Now we have already get that. We only have to do is to find the p. So again, if you have noticed, it's 4y. So you know what I mean. Therefore, our p is 1. Just like the first example do. And group the y plus 12 also. So now our p is equal to 1. And now we will gonna start our properties. Now since it is x squared, so we will use the fourth equation or the fourth formula. So our origin is so if you have to look this is x plus 2 quantity squared and y plus 12, no? So we can say that our x will be here, or our h is on the x, and the y is our k. So this time we have to interchange their signs. So negative 2 and negative 12. Okay, negative 12. And next is our foci. So since our foci is h and p plus k, so h will be 2, negative 2, negative 2, and our p is 1 minus 12. It will be negative already because multiplying unlike terms will be negative. And our directrix will be negative 1 plus negative 12. So if they have to check, it's k. Okay. And our axis of the parabola will be x is equal to negative 2. Okay. Now, since it's greater than 1 and it is x first, so it is upward. Let's take a graph right now. So our vertex is negative 2, 12, so it's on here and something here. Okay, then our vertex and our foci will be negative 2, and 1 minus 12, so it's negative 11. So let's stick here. It's negative 2 also, so negative. There. And our directrix is negative 1 and negative 12 will be 13. This is here. So we will draw. We have to take the approximate value of the given values. And our axis is x is equal to negative 2, which is here. So therefore, if we have to draw, since it's upward, we will look like this. So see? Now this is the graph of the given equation. Now let's go now to the fourth example. So y squared plus 6x plus 8y plus 1 is equal to 0. Now all we have to do is to regroup and to transfer. So y squared plus 8y is equal to 6x plus 1, then here negative also. We will change to negative. Sorry for these things. Anyway, so there. Now we have to do is same as we did earlier, completing the square. So y squared plus 8 divided by 2 is 4, and multiply itself is 16. So 16 is equal to negative 6 and negative 1 plus 16. And by that, we have to factor this. So y plus 4 squared. Now here is negative 6x and positive 15. Now, how do we get the p? Same as usual. Though we cannot multiply a whole number because there is no possibility that if we multiply it by 4, it will result to negative 6, right? So hence we will do the fraction. So therefore 4 times negative 6 over 4. Since if we have to multiply by 4, it will be cancelled out, right? And also here, but this time we will use the first numerical coefficient in the first term. So x and positive and multiply by positive, say negative 6, 15 over 6. Okay, it's positive here. So therefore, our p is negative. So before that, by the way, since negative 6 over 4 and negative 15 over 6 can be defined by the simplest form. So therefore, 4 times the negative 3 halves, because it's divided by 2, and also with this divided by 3 I mean, so it will be negative 5 halves. So therefore, our p here is negative 3 halves. Now we will use the following properties now: the vertex, the foci, and the directrix. As you can already know now what will be the vertex, right? So our vertex is negative 4, and positive 5 halves. Our foci is p plus h and k, right? So we have to add this. So negative 3 halves plus 4. Negative 3 halves is 4. So if we have to put some scratch here, so negative 3 halves plus 4. So let's say that you use this one. So find the LCD, which is 2, right? So 2 divided by 2 is 1 times 3 and negative 3. And 2 divided by 1 divided by 1 is 2 and times 4, 8. Therefore, it will be equal to 5 halves. And this will be our foci. It will be also a 5 halves, okay, already. So, now, our directrix is y. Let me think. Wait, it's y is equal to k, right? It is y. So, therefore, our directrix is y is equal to 5 halves also. And since our p is less than 0, it will go to the left. Let's graph. Our vertex is at origin. It's on the any point. So our vertex is negative 4 and 5 halves. So negative 4 and our 5 halves, if we were to divide it by 2, it's 2.5 here. So it's 2.5. Negative half x. So negative 4 and 2.5 here. And our foci here is very similar, so negative 5, and here, so there, if you have noticed, it is open to the left, so it would look like this, negative 3 halves, so 2 and, so take a look at this, okay, so, okay, good. Now you already know. So it's 5 halves and 5 halves, right? And you have to estimate this in accordance to the order. So this is outside of the foci, right? So I think we have to here. Now our directrix is y is equal to 5 halves. So here on the y. And 5 halves also. So we have to graph it now. This is open to the right. And that is now how, and that's how our parabola looks like. Since it was touched, since it was very touched. Wait, why did I draw this? There. Since it was very touched on this, you do not touch either. So in summary, the parabola is a set of all points in which it has equal distance between the directrix and the foci. And there are 4 equations that must be used to determine the graph of the parabola. 2 for the vertex at the origin, and the 2 will be on any point. And the following properties also would be given again. So I hope you guys understand, and sorry for my proficient English speaking because I don't know how, but instead I try my best to discuss you all, and hopefully you understand very well. You can also search anything and learn more about the parabola, or if not, you can watch here in my video. So this is for educational purposes only, and it is not intended for doing a video, not unless I was depending on my decision. So that's all, and have a blessed day.